The need for electricians in Iraq remains high due to ongoing reconstruction and infrastructure development efforts. Bechtel Corporation was awarded a multi-year contract in 2020 by the U.S. Agency for International Development to support the rehabilitation and expansion of Iraq's electricity grid. Bechtel is actively hiring electricians, instrumentation technicians, and other skilled personnel for this project. Other international contractors and organizations involved in Iraq's reconstruction efforts are also seeking electricians. The Iraqi government is investing heavily in electrification projects, creating opportunities for local and international electricians. Electricians typically need a high school diploma or equivalent, along with certification as an apprentice or journeyman electrician. Instrumentation technicians need a technical degree or certification in instrumentation and control systems. Experience in the construction or power industry is often highly valued. The job outlook for electricians and instrumentation technicians in Iraq is expected to remain strong in the coming years as reconstruction and development projects continue. LinkedIn and other job search platforms can be valuable resources for finding electrical and instrumentation jobs in Iraq. Contacting trade unions and professional organizations in the electrical and instrumentation field can also provide information on job opportunities. It's important to note that working in Iraq requires following security protocols and obtaining necessary visas and permissions. When considering a career as an electrician, it is important to understand the fundamental principles of electricity. These principles govern how electrical circuits function and are essential for safe and effective electrical work. One of the most important concepts is Ohm's law, which describes the relationship between voltage, current, and resistance in an electrical circuit. Ohm's law states that voltage equals current multiplied by resistance. This means that if you know any two of these values, you can calculate the third. For example, if you have a 12-volt source and a 6 ohms resistor, the current flowing through the resistor will be 2 amps. Another important concept is power, which is the rate at which electrical energy is transferred. Power is measured in watts, and it can be calculated by multiplying voltage by current. Understanding these basic principles is crucial for designing and troubleshooting electrical circuits. In addition to these fundamental principles, electricians must also be familiar with a variety of electrical components and their functions. Resistors are used to limit the flow of current in a circuit, while capacitors store electrical energy. Inductors create a magnetic field when current flows through them, and transformers are used to step up or step down voltage. Electricians must also be proficient in using a variety of electrical tools such as multimeters, ammeters, and ohmmeters. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. An ammeter is used to measure the current flowing through a circuit, while an ohmmeter is used to measure the resistance of a component. These tools are essential for troubleshooting electrical problems and ensuring that electrical systems are functioning properly. Electrical safety is also a critical aspect of the electrician's work. Electricians must be aware of the potential hazards associated with electricity, such as electric shock and arc flash. To protect themselves from these hazards, electricians must wear appropriate personal protective equipment, such as insulated gloves, safety glasses, and arc-rated clothing. They must also follow safe work practices, such as de-energizing circuits before working on them and using lockout/tagout procedures to prevent accidental energization. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Electricians must be familiar with the NEC and comply with its requirements to ensure that electrical installations are safe and code compliant. Some key aspects of electrical safety include proper grounding to provide a safe path for fault current, overcurrent protection devices like circuit breakers and fuses to prevent overloads and short circuits, and the use of ground fault circuit interrupters, or GFCIs, in wet locations to protect against electric shock. Article 250 in the NEC covers grounding and bonding requirements, ensuring that electrical systems are properly grounded to minimize the risk of electrical shock and equipment damage. Article 240 covers overcurrent protection, specifying the requirements for circuit breakers and fuses to protect circuits from overloads and short circuits. Article 210.8 covers ground fault circuit interrupter protection, requiring GFCIs in bathrooms, kitchens, and other wet locations to protect people from electrical shock. Understanding and adhering to these NEC articles is essential for electrical safety. Different types of electrical circuits are used in residential, commercial, and industrial settings. Residential circuits typically operate at 120 volts or 240 volts and are used to power lighting, appliances, and other household devices. Commercial circuits may operate at 120 volts, 208 volts, 277 volts, or 480 volts, depending on the type of equipment being powered. Industrial circuits often operate at higher voltages, such as 480 volts or higher, to power heavy machinery and equipment. The NEC specifies different wiring methods for different types of circuits and applications. For example, non-metallic sheath cable, or NM cable, is commonly used for residential wiring, while electrical metallic tubing, or IMT, is often used for commercial and industrial wiring. The choice of wiring method depends on factors such as the voltage of the circuit, the environment in which the wiring will be installed, and the type of building construction. Electricians must be knowledgeable about the different wiring methods and their applications to ensure that electrical installations are safe and code compliant. Electrical blueprints and schematics are used to represent electrical systems and circuits. Blueprints show the physical layout of electrical equipment and wiring, while schematics show the electrical connections between components. Electricians must be able to read and interpret blueprints and schematics to install and troubleshoot electrical systems. Blueprints typically include information such as the location of outlets, switches, and lighting fixtures, as well as the size and type of wiring to be used. Schematics use symbols to represent electrical components such as resistors, capacitors, and transistors, and lines to represent the connections between them. By studying blueprints and schematics, electricians can gain a clear understanding of how an electrical system is designed to function. Troubleshooting electrical problems involves identifying the cause of a malfunction and taking corrective action to restore the system to proper operation. Electricians use a variety of tools and techniques to troubleshoot electrical problems, such as visual inspection, voltage testing, continuity testing, and resistance testing. Visual inspection involves looking for obvious signs of damage, such as broken wires, loose connections, or burned components. Voltage testing involves using a multimeter to measure the voltage at different points in a circuit to determine if voltage is present where it should be and absent where it should not be. Continuity testing involves using a multimeter to check if there is a continuous path for current to flow between 2 points in a circuit. Resistance testing involves using a multimeter to measure the resistance of a component to determine if it is within its specified range. By systematically testing different parts of a circuit, electricians can isolate the cause of a malfunction and take corrective action. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. Electricians must stay up to date on the latest code changes to ensure that their work is compliant with current regulations. The NEC is updated every 3 years, and each new edition includes changes and revisions to existing requirements. Electricians can stay informed about code changes by attending training courses, reading industry publications, and participating in professional organizations. By staying current on code changes, electricians can ensure that their work is safe, reliable, and compliant with the latest standards. Continuous learning and professional development are essential for electricians to maintain their skills and knowledge throughout their careers. Electricians can pursue a variety of educational opportunities, such as apprenticeship programs, vocational schools, and online courses. Apprenticeship programs provide on-the-job training under the supervision of experienced electricians, while vocational schools offer classroom instruction in electrical theory and practice. Online courses provide a convenient way for electricians to learn new skills and stay up to date on the latest technologies. By investing in their education and professional development, electricians can enhance their career prospects and increase their earning potential. The skills and knowledge of electricians are essential for maintaining the safety and reliability of electrical systems. Electricians play a critical role in ensuring that homes, businesses, and industries have access to safe and reliable power. Their work involves installing, maintaining, and repairing electrical systems, as well as troubleshooting electrical problems and ensuring compliance with electrical codes and standards. Electricians must be knowledgeable about electrical theory, wiring methods, safety practices, and troubleshooting techniques. They must also be able to read and interpret blueprints and schematics and use a variety of electrical tools and test equipment. By applying their skills and knowledge, electricians help to keep the lights on and power the world around us. When dealing with electrical panels, it is important to follow specific safety procedures to prevent electrical shock and other hazards. Firstly, always wear appropriate personal protective equipment, including insulated gloves and safety glasses. Secondly, ensure that the area around the electrical panel is clear of any obstructions and that there is adequate lighting. Before opening the panel, use a non-contact voltage tester to verify that the panel is not energized. If the panel is energized, do not attempt to open it. Instead, contact a qualified electrician to de-energize the panel. Once the panel is de-energized, use a multimeter to verify that there is no voltage present. When working inside the panel, use insulated tools to prevent accidental shorts. Never touch any bare wires or terminals. When replacing circuit breakers or fuses, use the correct size and type. Overcurrent protection devices are designed to protect circuits from overloads and short circuits. Using the wrong size or type of overcurrent protection device can create a fire hazard. After completing any work inside the panel, carefully inspect all connections to ensure that they are tight and secure. Replace the panel cover and secure it with screws. Finally, verify that all circuits are functioning properly before leaving the area. Following these safety procedures can help prevent electrical accidents and ensure that electrical panels are safe to operate. When working with high voltage systems, it is essential to follow strict safety protocols to protect yourself from electrical shock and other hazards. Firstly, only qualified and trained personnel should work on high voltage systems. Secondly, always de-energize the system before working on it. This involves disconnecting the power source and verifying that there is no voltage present using a high voltage tester. Thirdly, use appropriate personal protective equipment, including insulated gloves, safety glasses, and arc-rated clothing. Fourthly, establish a safe work zone by using barricades and warning signs to keep unauthorized personnel away from the area. Fifthly, use insulated tools and equipment that are rated for the voltage level of the system. Sixthly, never work alone on high voltage systems. Always have a qualified observer present who can provide assistance in case of an emergency. Seventhly, follow lockout/tag-up procedures to prevent accidental energization of the system. Eighthly, inspect all equipment and tools before use to ensure that they are in good working condition. Ninthly, be aware of the potential hazards associated with high voltage systems such as arc flash and electric shock. Tenthly, develop and follow a written safety plan that outlines the specific procedures to be followed when working on high voltage systems. By following these safety protocols, you can minimize the risk of electrical accidents and ensure that high voltage systems are operated safely. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and clear faults quickly. Bonding connects all metal parts of an electrical system together, which helps to equalize voltage and reduce the risk of electric shock. The NEC specifies detailed requirements for grounding and bonding in Article 250. These requirements cover a wide range of topics, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the requirements for bonding metal enclosures and equipment. One important aspect of grounding is the use of a grounding electrode system, which consists of one or more grounding electrodes that are connected to the earth. Common types of grounding electrodes include ground rods, ground plates, and underground water pipes. The grounding electrode system must have a resistance to ground of 25 ohms or less. Bonding is typically accomplished by using bonding jumpers to connect metal parts together. Bonding jumpers must be sized according to the size of the circuit conductors. The NEC also requires that all metal water pipes that are likely to become energized be bonded to the grounding electrode system. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. Regular inspections and testing of grounding and bonding systems are necessary to ensure that they are functioning properly. Electrical inspections are conducted to ensure that electrical installations are safe and code compliant. Electrical inspectors are typically employed by local government agencies or private inspection companies. They are responsible for reviewing electrical plans, inspecting electrical installations, and issuing permits and certificates of occupancy. Electrical inspections are typically required for new construction, renovations, and additions. The scope of an electrical inspection depends on the type of project and the local codes and regulations. During an electrical inspection, the inspector will check for a variety of things, such as proper wiring methods, overcurrent protection, grounding, and bonding. The inspector will also verify that all electrical equipment is installed according to the manufacturer's instructions. If the inspector finds any deficiencies, they will issue a notice of violation. The property owner or contractor is responsible for correcting the deficiencies and scheduling a re-inspection. Passing an electrical inspection is essential for ensuring that electrical installations are safe and code compliant. Regular electrical inspections can help to prevent electrical fires and other hazards. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other disturbances on the electrical grid. SPD work by diverting excess voltage away from sensitive equipment. There are two main types of SPD. Type 1 SPD are installed at the service entrance of a building and are designed to protect the entire electrical system. Type 2 SPD are installed at the branch circuit level and are designed to protect individual pieces of equipment. SPD are rated according to their surge current capacity, which is the amount of current that they can safely divert. The higher the surge current capacity, the better the protection. SPD should be installed by a qualified electrician. They should be inspected regularly to ensure that they are functioning properly. Replacing SPD every few years is recommended, as they can degrade over time due to repeated surges. Installing SPD is an effective way to protect valuable electrical equipment from damage caused by voltage surges. Arc flash is a dangerous electrical hazard that can occur when there is a fault in an electrical system. An arc flash is a release of energy in the form of heat, light, and pressure. It can cause serious burns, blindness, and even death. Arc flash hazards are present in all electrical systems, but they are more common in high voltage systems. Arc flash can be caused by a variety of factors, such as accidental contact with energized equipment, equipment failure, or improper maintenance. To protect workers from arc flash hazards, employers are required to conduct arc flash hazard assessments. These assessments involve identifying potential arc flash hazards and determining the level of protection required. Workers who are exposed to arc flash hazards must wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields. They must also be trained in arc flash safety procedures. Reducing the risk of arc flash involves implementing safety measures such as de-energizing equipment before working on it, using insulated tools, and maintaining equipment properly.